Okay, so we're going to look at doing some domains algebraically. So point of this is doing it algebraically, not doing it with a graphing calculator. One thing to realize with domains, we want no 0 in the denominator, no negative under a radical, and no, so let's say we have a denominator and a radical in the denominator. We don't want a negative or 0 then, if that radical is in the denominator. Okay, so when I look at the first polynomial, since it's a polynomial, domain of any polynomial is all reals. So I would say my domain, I could use that R with the double line. I could also say negative infinity to positive infinity. Okay, if I have a fraction, what I do is I look at the numerator first. Numerator is a polynomial, all reals. Then I do not want the denominator equal to 0. So I would set the denominator equal to 0, and anything that makes that denominator equal to 0, I would exclude out of the domain. Well, what we're going to see here, I square root, this is x is plus or minus the square root of -1, which is imaginaries, which means there's nothing that's going to need to be excluded from the domain. So the domain is going to be all reals. Next fraction, numerator is a polynomial, so it's all reals. Denominator, I want to set x squared minus 4 equal to 0. When we square root, we get plus or minus 2. That means x can't be plus or minus 2. So we're going to say all reals except for 2, -2. That is my domain. Now, with a square root, we said the square root being in the numerator can't have a negative, which means what's under the square root could be anything greater than or equal to 0. Can't be negative, so it can't be less than 0, but it could be greater than 0, or it could be equal to 0. So if I solve this, x is less than or equal to 1, which is my domain. Or I could say negative infinity to 1, hard bracket, if I wanted to do interval notation. E here is showing the difference of if the square root is in the denominator. So I still look at the numerator. Numerator's all reals because it's just a polynomial. Denominator has a square root. So that x minus 9 is going to have to be greater than 0. Can't be negative under the radical. Can't also be 0 because that radical is in the denominator. We don't want 0 in the denominator. So this is x is greater than 9. So my domain, x is greater than 9, or I could say soft bracket 9 to infinity. Next one's basically the same. You look at the numerator, it's all reals. You take the denominator and just set it greater than 0. And that's again because it's in the denominator. Divide by a -1. Remember with inequalities, when you divide by a negative, you have to flip the inequality. So it would be x is less than -2 or negative infinity to -2. All right, now they're going to get a little bit harder. If I look at the numerator is not all reals anymore. There is a radical in the numerator. So x plus 3 I know has to be greater than or equal to 0, which means x has to be greater than or equal to -3. However, the denominator, x can't be 2, because that would make my fraction undefined. One way we can say this is we can just say x is greater than or equal to -3, but then comma x cannot be 2. The other way we can do it is it's kind of like we're saying, okay, we're saying x is anything greater than or equal to -3, but we don't want 2 in there. So then in interval notation, I could say -3 to 2, soft bracket, and then 2 to infinity. I don't want the 2 counted in there. For this next one, we take what's under the square root, set it greater than or equal to 0. Now, this is a good review from the last unit. When we have an inequality degree 2 or higher, we have to partition the number line. So if I multiply that through, it'd be an x squared. So that's degree 2 or higher. So we pick something to the left of -2, like -3. That's negative, negative, which is overall positive. In between, we pick 0. That's plus, minus, which is minus. To the right of 3, I'd pick 4, which is plus, plus, plus. Greater than 0, that looks like my answer. Now, however, that was just considering the numerator. The denominator, we know x cannot be -1 and x cannot be 4. So let's look. Based on where my number line shaded, is -1 a possible answer? No, because -1 is in here. So -1 wasn't going to be part of my answer anyway. Is 4 a possible answer? Yeah, 4 is right here. We don't want 4 as part of the answer. This one, since there's so many pieces to it, the way we'd write it is the interval notation. We'd say -infinity to -2, u. Then we'd say 3 to 4, soft bracket on the 4, because we don't want to count the 4, and then 4 to infinity. So just reading what I have off of the number line. Algebraic functions. To get the domain, look at both the f of x and g of x and the final answer. To do f plus g of x, you take the f of x, add the g of x. To do f minus g of x, you take the f of x function, subtract the g of x function. F times g of x is the f of x function times the g of x function. And f divided by g of x is the f of x divided by the g of x, where g of x does not equal 0, of course, because otherwise it would be undefined. So we're going to find these and their domains. So when I'm doing f of x plus g of x, I just take the f of x function and add it to the g of x function. So that'd be f of x plus g of x. That would be my answer to f plus g of x. Now, as far as the domain goes, I have to look at both of the originals and the final answer. Well, here the domain is all reals. Here, x plus 1 has to be greater than or equal to 0 because it's a square root. So x is greater than or equal to -1. Since this is more restrictive than all reals, that's the one we have to use. The final answer doesn't restrict it anymore. That's just it. F minus g of x, it's the f of x minus the g of x. So I take the f of x function and I subtract the g of x function. Again, domain is going to be x is greater than or equal to -1. F times g of x, we take the f of x, we multiply by the g of x. So that's our answer. Domain, still x greater than or equal to -1. Now, where the domain's going to change is in the next one, because we take the f of x over the g of x. Now, the final answer does have more of a restriction, right? Because when we were just doing the domains, we said if you have a fraction, you look at the numerator. If the numerator is all reals, which it is, it's x squared. So far, it's all reals, but the denominator cannot be 0, and that x plus 1 cannot be negative because it's under the square root. So I have to say x plus 1 has to be greater than 0. X has to be greater than negative 1. It can no longer be equal to negative 1 because I'd have 0 in the denominator. Now for g over f, let's see, so that's this over this. Okay, so for domain, x plus 1 can be greater than or equal to 0, right? But x squared can't be equal to 0, which the only thing that would give x squared equal to 0 is x is 0. So my domain, I could say x has to be greater than or equal to negative 1, comma, x cannot be 0, because that would make the bottom of the fraction 0. Or you could say, hard bracket, negative 1 to 0, 0 to infinity. So basically, greater than negative 1, but you have to take 0 out of there. This is more of the same thing. The only thing is if, you might see ones like this, if you see it in the book, they might take, when you do f of x plus g of x, since this can be simplified with a common denominator, that's probably what they're going to do. So this has the x plus 2, it needs the x minus 1. This has the x minus 1, it needs the x plus 2. So this would be x squared plus 3x minus 1 over x minus 1, x plus 2. So that type of thing. You could actually simplify this a little more. That's all that's showing. As far as domain, when I look at the numerator, it's all reals. The denominator can't be 1 or negative 2. That, again, I won't go through the whole common denominator. Well, I'll just tell you what you're going to get. You're going to get negative x squared minus x minus 1 over x plus 2, x minus 1. So when we go to do the domain, same thing, all reals except for 1 or negative 2. Multiplication, we are going to take 1 over x plus 2, multiply by x over x minus 1. So we get x over x plus 2, x minus 1. For the domain, numerator's all reals. Denominator, though, can't be negative 2 or 1. F over g of x, we are going to take the f of x, divide by the g of x. Remember, with fractions, when you're dividing, you are going to multiply by the reciprocal. And so in this case, numerator is all reals, denominator can't be 0 or negative 2. So the domain is all reals except for 0 or negative 2. Oh, or what's inherited from the original problem, we also need to exclude 1. Now, 1 is not excluded because of the final answer. 1 is excluded because of the original problem. This was all reals except for 1. This is all reals except for -2. And the final answer in part D also excluded 0. So remember, in the beginning, it said you have to look at both of the originals and the final answer. So anything that has to be excluded in both the originals or the final answer has to be excluded. Okay, that's it for the day 4.